Section 9.2 is about estimating a population mean. So section 9.1 was about proportions, and now we're going to do the exact same thing for estimating means. So we're going to talk about a point estimate for a population mean, talking about something called a t-distribution, which is something new, find and calculate t-values, which are very similar to z-scores. Then we'll learn how to construct confidence intervals for a population mean, and find those minimum sample sizes with given margins of error and confidence, just like we did in section 9.1, just this time with means instead of proportions. Again, if you have that comparison chart from chapter 8, section 9.1 was all about proportions, and here we use z critical values. And then section 9.2, sorry, you can't see that, section 9.2 is about means, and we use what are called t critical values. So let me write that again. Section 9.1, z critical values for proportions, and section 9.2 is about t critical values for means. So all of these properties that were true for proportions, now we're going to switch gears into all of the properties that are true for means. So very parallel, just one with proportions and one with means. All right. So for section 9.2, we're going to be given a random sample of fuel efficiencies for a 2007 Ford Taurus. And we're going to obtain a point estimate for the population mean miles per gallon of a 2007 Ford Taurus. So here's our sample. I believe there are 1, 2, 3, 4, 5, 10, 13 values. And if we wanted a sample mean for these, we would just add them all up and divide by 13. Or we could put them all in L1 and do a 1-var stats, which is what I'd like you to do, because we're going to be using these later. So if you go in your calculator under stat edit, clear out whatever's there, hitting clear and then enter. Type in the fuel efficiencies in any order, everybody in L1. 26, 23.5, 23.4. So you should have 13 values in L1. If you go to stat calc 1-var stats, that should give you that same value, the x bar of 24.13. And I'd also like to write down the standard deviation for the sample, which is 3.21. We're going to be using those values a little bit later. But for now, we're looking at the point estimate of 24.13 miles per gallon. So keep this page handy. We're going to be referring to it again towards the end of this section. So we have what's called a t-distribution. We will be constructing confidence intervals for means very similar to how we created them for proportions. The mean of a sample distribution is equal to the mean of the population, just like chapter 8. And remember that the standard deviation is adjusted by dividing by the square root of the sample size. Again, just like chapter 8. These two properties are the same things we wrote down in our comparison chart, mean and standard deviation. All right. So we're going to be making a slight adjustment. It is likely that since we do not know the population mean, we also do not know the population standard deviation. Therefore, instead of calculating a z-score, we're going to calculate something called a t-score value, which uses the sample standard deviation instead of the population standard deviation. Don't want to worry too much about the differences here. Just know that for means, we're using a t-score, and for proportions, we're using the z. The book talks about how to calculate a t-score. You take your x bar minus your mu, you use your sample standard deviation, and divide by the square root of n. I don't recall needing this particular formula. It is on your formula sheet. Let's see. It is somewhere. It is, I believe it's under chapter 10. So it's right there under chapter 10. If you need it, I don't think you do. It's just an adjusted z-score formula. So that is there. I think that's more for chapter 10, though. We shouldn't need that for chapter 9. The only thing we need to remember here is that n minus 1 is what we have for the degrees of freedom, which I know we've mentioned previously. Just remember that degrees of freedom, or df, is always 1 less than the sample size. So this is our slight adjustment when we're dealing with samples instead of parameters. So it allows for some buffer since we're dealing with this sample. So again, degrees of freedom is just n minus 1. We're going to need that to help us with the z-scores. So these z-scores or z-values, I'm sorry, not z, t-scores or t-values are interpreted the same way z-scores are. There's a different chart that we're going to use, which is Table 6, that has been adjusted based on sample size and is listed using the degrees of freedom for the particular problem. So if you look in your formula book, Table 5 has the z at the top. You'll see the z in the top corner, the table we were using in Chapter 7. And now we're going to be using Table 6, which is the t distribution. You'll see the t at the top, and you'll see the degrees of freedom, the df, down the side. So this chart's organized a little bit differently based on degrees of freedom, and I'll explain what that is in just a minute. So have that handy. All right. So let's find the t-value such that the area under the curve on the t-distribution to the right of the t-value is 0.10, assuming 15 degrees of freedom. That would mean that your sample size was 16. So we're looking for a t-score with an area to the right of 0.10 and 15 degrees of freedom. Now we're used to looking to the left. So Table 5, the z-scores look to the left. Another thing that's different about t-scores is we're talking about area to the right. Everything's symmetrical, so it's not that big of a deal. Just remember that these values are to the right of the t-score. So here are the different areas. We want 0.10, so here's 0.10. And then we want 15 degrees of freedom. So there it is on the side. So there's 15, and we go down, and it's 1.341. So the t-score that we're looking for is 1.341. You can also get this in the calculator. Let me show you. By doing second bars. And the fourth option is inverse t. Now the older calculators, the older TI-83s do not have this feature, but that's okay because you have your chart. If you have a TI-84, if you go to inverse t and put in, the area 0.10, the degrees of freedom 15. It takes it a minute, but it will give you the same value. It always gives you a negative, but we don't need to worry about the negative. So these are our critical values for confidence intervals for means. We use the t-values. So 1.341. So you can use a chart or you can use inverse t in the calculator. So constructing a confidence interval for means, pulling all this together, we're going to check our assumptions. The assumptions for means are different. Remember, it can be stated that it's normally distributed, or the sample size can be greater than or equal to 30, or we can look it up in the normal plot. I'll remind you how to do that in just a minute. Then we'll find our critical t-value from the chart or the calculator. Then the similar construction, this time you have x bar plus or minus the t critical value, so t of alpha over 2, times the standard deviation, which is s over radical n. So it's still point estimate plus or minus critical value, just like it was in section 9.1, times the standard deviation. So students get really bogged down in these formulas, and if you can remember the big idea, the main setup of how this works, the point estimate plus or minus the critical value times the standard deviation, it will make these a little easier to look at. So on your formula page, at the bottom of the page, here's the one we looked at for section 9.1. And here's the one we're going to use for section 9.2. X bar plus or minus the critical value for t times s over radical n. So it's very, very similar in setup. You can also go to stat tests, and there's one called t-interval, which you can choose, and then you'll interpret your interval by stating your conclusion. So let's run through this with an example. So using the sample data from example 1, construct a 95% confidence interval for the mean miles per gallon of a 2007 Ford Taurus and interpret the interval. So step 1 is to check your assumptions. This is using this original data. We only have 13 in our sample, so our sample is not big enough to say that it's normally distributed. If you have all your values in L1, which you should, you can go to second y equals, just like we did in chapter 7, choose that last grid, and make sure it says L1 and everything's good, and then zoom 9. And remember, if these dots line up approximately in a straight line, we can say that the data are approximately normal. So I'm using these 13 data points, going to stat plot, turning it on using that last option, and then hitting zoom 9, and those values should line up roughly linear. So you should take your pencil, should be roughly linear, which they are. So step 1, the normal plot is roughly linear. Therefore, we can assume that it's approximately normally distributed. Step 2 is to find that critical value, so I'm going to do inverse t. Now if I want a 95% confidence interval, remember that leaves 0.025 in the tail, so it's going to be 0.025. And our sample size was 13, so our degrees of freedom is 12. Again, we're using this original data from the beginning. And that's going to give me inverse t of 0.025 with 12 degrees of freedom. It always takes it a minute to think. We don't have to worry about the negative 2.17. I'm going to round that to 9. Or you can put 88. If you want 4 decimal places, 2.1788. You can also look that up in the chart. Let me just show you. In table 6 at the very back, we can look up 0.025, degrees of freedom of 12, and it gives us roughly the same value, 2.179. So either way, you get roughly the same critical value. Now for step 3, I like to see the setup of your construction. So we're going to use, of our interval, we're going to use the numbers we know. We know that the point estimate is 24.13 plus or minus that critical value we just found, 2.179, times the sample standard deviation over the square root of the sample size. So I like to see the setup. Your homework likes to see the setup. And then we can let the calculator give us the actual interval. So stat tests. We're going to go down to z interval, which for me is option 7. We either have data or we have the stats. Now in this example we have, I chose z interval, I'm sorry, t interval, option 8. We have the data or the stats. The data means that you've put values in L1, which we have. If you change it to stats, it looks very different. So make sure data is selected. Our list is in L1. The frequency will stay at 1. The confidence level will be given to you in the problem. We're doing 95%, so 0.95. And then all I have to do is hit calculate. Again, it takes it a minute. 22.192 to 26.069. It also states the x bar and the s of x, which should match from before. And then if we want to interpret our interval, we would say we are 95% confident that the true mean miles per gallon of a 2007 Ford Taurus is between, and we can round off here, I would say 22 and 26 miles per gallon. So our sample gave us about 24, plus or minus this margin of error gives us between 22 and 26 miles per gallon. Have another example, similar situation of constructing a confidence interval. So I'm going to do this, work this out on a separate sheet of paper. This is from page 414, section 9.2, question number 31. It says, how much do you read? A recent Gallup poll asked 1,006 Americans, which I like to make a note of that while I'm working, during the past year about how many books, either hardcover or paperback, did you read either all or part of the way through. Results of the survey indicate that the sample mean is 13.4 books and the sample standard deviation was 16.6 books. Construct a 99% confidence level, 99% confidence interval for the mean number of books that Americans read either all or part of the way through during the preceding year. So what that means here, remember we talked about if it gives you a standard deviation, that helps you decide that we're talking about means. If it does not, or it gives you a percentage, we're usually talking about proportions. So here's the information that we need. We need to check our assumptions first. Is our sample size greater than 30? Yes, it is. So we know that it's normal. Let's find that inverse t-value, either again in the chart or in the calculator. 99% confidence leaves 0.005 in the tail, and our degrees of freedom would be 1,005. So let's do that. Inverse t under second bars, 0.005 and 1,005. It always takes it a minute. You don't need the negative, 2.5807. And then for step 3, I like to see the setup. We have our x bar, 13.4, plus or minus the critical value. I'm going to round that off to 2.581 times s of x over the square root of the sample size. Now that setup is very important. There are problems that ask you for just the setup. But once you get the setup, you can just use the calculator, stat test, t interval. This time instead of data, we have, stat test. Instead of data, we have stats. We don't have the list of 1,006 values. We just have the statistics. So you can clear out whatever's there, and we're going to put 13.4. For s of x, you can clear out whatever's there, 16.6. Our sample size is 1,006. We just go down the list. We want 99% confidence, so 0.99, and then calculate. So it just asks you for the statistics that it gives you in the problem, and then calculate. And our answer would be 12.049 to 14.751. Then we can interpret that by saying we are 99% confident that the mean number of books read is between, and you can round this off, I would say 12 and 15 books. So you can round off when you state your conclusion. That's a full write-up. You check your assumptions, you find your critical value, you set up your formula, then you can use the calculator to get the actual interval, and you state your conclusion. I'm going to pause there, and then I'll finish section 9.2.